All right, guys, so we are going to focus on some motion graphs. In class lately, we've been talking about how to calculate speed, and we know that speed involves distance and time. So when we talk about a graph, again, if these are speed graphs, we have our variable distance, which again could be meters, centimeters, and all that, and then we have time. Time is always going to go on the x-axis, okay? And this is your independent variable because time is never going to change. A second is always going to be a second, which is going to be a second. So what does change based on our time is our distance. What I mean by that is if you were going to say, hey, you have 5 seconds to make it to that door. Well, my time's not going to change. I might make it and I might not based off of my speed. And that's going to determine why this is independent and that's dependent. Okay? So I want you to look at the green line. Okay? If this is a speed graph, what can you tell me about the speed of this object? Well, first off, you can tell me that it is very, very fast because look how vertical it is. I mean, we covered a distance of 1, 2, 3, 4, 5, 6, 7 lines in about 3 seconds if we wanted to make each line a second. That's really fast. What we also know is that it is at a constant speed. And the reason I know it's at a constant speed is because the line is straight. So you can always tell if speed is constant on a graph because it will always be represented by a straight line. So let's look at the blue line. Notice how the blue line is not straight. It has a bend to it. So right off the bat, you can tell that this is not a constant speed. It is increasing, decreasing, accelerating, deaccelerating. So notice that we start moving slow, and then we start increasing our speed and going faster. Okay, so it's kind of like when I pull out onto a highway. I kind of go a little bit slow, and then once I get on that highway, I'm increasing. I'm going faster. I'm not going at a steady speed. But I'm still not as fast as the green line. Okay? And then let's look at the red. The red, notice how from here to here, it is a straight line. So that must tell us that it is constant. Now, what happened at the 3 seconds all the way to the 7? It's horizontal. Notice the distance didn't change. If you ever see a straight line on a speed graph, that means the object stopped moving. So then why is the line still going? Because time still goes, if that makes any kind of sense. So think about it. It's like I decide, hey, I'm going to get up and I'm going to walk to the elevator. Okay? So I walk to the elevator and I push the button. Now I'm just standing there. Well, time's still going on, but I'm not moving anywhere. And then I decide, oh, this is too long. And I turn around and I go to the stairs. So notice how this line right here, this is what we call a negative slope. My distance is decreasing, but my time is still going. So that must mean I'm returning back to my start. And again, because it isn't a straight line, it's at a constant speed. I know this seems like a lot, and hopefully you're taking really good notes, but I promise we're going to practice and it's going to get better. So let's look at this graph. Which graph shows the object traveling at the fastest speed? Graph A or graph B? So pause it and decide. Actually, I want you to pause it and I want you to draw the graph that you think is correct. Ready? All right, well, the answer is B. Okay, so let's go back and look at it. Sorry. Notice that you can tell B is a faster graph because it is moving at a higher line. The higher, the more vertical a line is, the faster the speed. The lower and more horizontal a line is, the slower the speed. So let's look at question 2. Which part of the graph shows that an object is stationary? Okay, if you want to pause this and go back and look at your notes, that's fine, but I want you to write your answers down so we can check this. In fact, go ahead and write your answers in the left column for question 2. So all you need to write is question 2. Do you think it's A, B, or C? Which part of the graph shows a stationary line? Now, I'm not going to answer this one because I want to check it in class tomorrow. So A, B, or C? Question 3. Which line shows an object that is accelerating? Accelerating means it is speeding up and moving faster. Do you think it is object A or object B? Again, I'm not going to answer it, so write this in your notes and we're going to go over it tomorrow. But you must have an answer. Do not leave it blank. Question 4. How far did object A travel? Okay, so here's our line. Notice if we're talking about how far something travels, do we want to look at the distance or do we want to look at the time? So go ahead and pause the video. Use your finger to kind of make the lines go to the distance. Do you think it's 50 meters? 50 meters, 100 miles, or 50 meters? And I did not type this, so I did not spell meters wrong, so don't come back at me on that. I know how to spell meters, all right? So write 50 meters, 100 miles, or 50 or 100 meters. Question 5. What was the speed of object A? Okay, here we go. So object A, notice it has a distance. If you take your 20 and you go over here, where do you hit it? Right here. And you go down to about here. So if you don't like where those numbers are, you can try to find one that's better. It's okay. So I like to find easy numbers, so I'm going to go where here in 10 seconds is. Go up, go over, okay? Try to figure out what this number is and divide the 50 by 10 and tell me what the speed is. Okay, and I'm kind of helping you a little bit on this one. So the answer should be 5. All right, number 6. Which part of the graph shows the object that is returning to start? Again, look in your notes. Do you think it's A, B, or C? Question 7. Which part of the graph shows that the object is traveling at a constant speed? A, B, C, or A and B, B and C, or A and C? Now, this one is a tricky one. Question 8. How long was the cyclist stationary for? Okay, so how long? That means we're looking for a unit of time. So you need to figure out where the line is straight and then add the times together. So do you think it's 80 seconds, 40 seconds, or 220 seconds? Okay? All right. So if you need to rewind this at any time, go ahead and do so. And tomorrow in class, we will be going over the answers. Bye.